And now the three last lectures will be convened by Dr. Sinaya Netanyahu. She is the Chief Scientist of the Ministry for the Protection of Environment, and she is also deeply involved in climate change.
Okay, so we are going to focus in the coming hour on climate change impact on birds population, on biodiversity in Israel, and on the body size of birds and mammals. The first speakers will be Mr. Scott Weidensaul and Steve Kress, and let me just say a few words. Scott is the author of more than 2,000 books on natural history, including the Pulitzer Prize finalist Living on the Wind Across the Hemispheres with Bird Migration and Return to Wild America, a year-long search for the continent's natural soul, and is a contributing editor of the Audubon magazine. And Dr. Steve Kress is a Vice President for Bird Conservation for the National Audubon Society, manager of the Society's main coast Seabird sanctuaries, and director of the Hog Island Audubon Camp. So we're going to have the two speakers in the next 25 minutes.
Thank you. Oh. Actually, just one speaker. Steve was not able to make it. I'm here. I'm a bit of a fraud, I have to say. I study owls and hummingbirds, but I'm going to be speaking to you today about Steve Kress's research on seabirds. I'm just going to shift gears slightly here. Global warming has a number of effects on seabirds. One is simple ocean water rise from thermal expansion and from polar melt that floods out nesting areas. You can have more severe storms that cause habitat erosion and flooding, more extreme rain events that are caused by increased evaporation. Acidification, which is where the carbon dioxide that's released from fossil fuel burning is turned into carbonic acid, which can increase the acidity of ocean water and can actually dissolve the calciferous shells of marine invertebrates and mollusks, including those that the zooplankton on which the forage fish feed, on which these seabirds depend. So these are all some of the effects that we're going to be talking about today. On the other hand, active management can preserve and increase the populations of some of these seabirds that are feeling the effects of global warming. And one of them is the cahal, the Bermuda petrel, which was considered extinct by the 1600s. It was eaten out of existence by early settlers in Bermuda. It was also wiped out by rats and cats that were introduced there. It was rediscovered in 1935, and as recently as 2000, there were only about 60 pairs, just very, very, very slow recovery. The problem is that the tiny little offshore islands where the cahal breeds are eroding and crumbling into the sea because of ocean level rise. And so there's been an effort in recent years to try to move the cahal to safer breeding islands in Bermuda. Between 2004 and 2008, about 105 cahal chicks were moved from the traditional breeding islands to an island called Nonesuch Island, which is somewhat larger, somewhat more secure, and which, thanks to the efforts of people like David Wingate, who's been working with cahal petrels since he was a teenager, has largely been revegetated in native forest. The rats and other invasive species have been eliminated. And in 2009, cahal petrels bred on Nonesuch Island for the first time in recorded history. And as of this year, there were 109 pairs, up from 60 just a couple of years ago, 13 of which were nesting on Nonesuch Island. So it's an example of how, even in the face of significant changes and significant challenges, it's possible to use active management to offset the effects of global warming on seabirds. And this is something that goes back more than 40 years. My friend and colleague, Dr. Stephen Kress from the National Audubon Society, really was the pioneer of active seabird management. Started 41 years ago on the Gulf of Maine on the northeastern coast of the United States, working with Atlantic puffins. This was a bird that had been extirpated from the southern edge of its breeding range in the late 19th century, and Steve had the idea of trying to bring these birds back to the Gulf of Maine, something that nobody had ever tried before. And the focus of this is seven, got a little pointer right here, 7 managed seabird colonies along the coast of the northeastern coast of the United States in Maine. It says right up in northern New England, and Wrong button. One of the islands we'll be talking about is Eastern Egg Rock, which is relatively small. It's only about 7 or 8 acres. This was the first island to which puffins were reintroduced starting in the early 1970s. Another of the largest of the seabird colonies now is Seal Island National Wildlife Refuge. It's about 30 hectares or so in size, has a large colony now of restored puffins and other seabirds. In 1973, Steve and his colleagues began bringing puffins down from Newfoundland in Canada. They moved about 1,000 chicks over the course of about 15 years, translocated them to artificial burrows on Eastern Egg Rock, fed them by hand, banded the birds, released them, didn't know actually whether these chicks would return, and so they pioneered a number of techniques to try to lure them back to the island. They used artificial decoys. They used mirrors, because if you've ever had a pet parakeet, you put a mirror in the cage and it thinks it's another bird. The same thing works with puffins. They also, they're cute birds, they're not necessarily the brightest things on God's earth. But what has proven extremely successful with puffins, with cahal petrels and other seabirds, is using acoustic lures, using recordings of a loud, noisy seabird colony. You play this recording at loud decibels, and it sounds like a seabird colony. It attracts these birds, especially the young birds, before they have begun their breeding. Puffins are unique in a couple of ways. Their incubation period is always exactly 42 days. The egg is always incubated for 42 days before hatching. But the nestling period, the time that the chick is in the nest, varies from as little as 38 days to as much as 62 days, depending on the productivity of the water, depending on how much good quality food is available for that bird. Puffins breed in burrows underground, and burrows are the single most important and scarce commodity in a puffin colony. So after the chick leaves the nest, it goes off to sea by itself. Its survival is going to depend on entirely on the productivity of the sea. It gets no help from its parents. Once it fledges, the parents remain back on the island to guard that burrow to make sure that another pair of puffins doesn't take it over for next year. If the chick is not able to find high quality food in good number, it's not going to survive. We don't really know where the chicks go during the winter, during the non-breeding season. Only in the last couple of years have Steve and other scientists involved with Project Puffin began to use geolocators to track the movements of the adult birds. This shows the movements of adult puffins in the North Atlantic all the way up to the Davis Strait between Canada and Greenland, and all the way down to Bermuda. But puffins are utterly and completely dependent on cold water. And the Gulf of Maine, even though from a United States perspective is fairly far north, it's actually pretty far south for a seabird. And the cold water there comes down in currents that spawn up between Greenland and Canada. The Labrador Current brings this cold water south. There's a whole host of offshoot currents that swirl it down into the Gulf of Maine, which is right down here, below Nova Scotia. And that cold water allows the phytoplankton on which the forage fish depend. The forage fish are cold water species on which the puffins depend. And so every spring, if you look at the bloom of phytoplankton, the bloom of tiny little microscopic plants in the water, in March off Cape Cod, you start to see the red of the phytoplankton bloom. By April, there's just an explosion of plant life in the Gulf of Maine, this extremely cold, nutrient-rich water that is just seething with life. And that's mostly gone by May because most of that phytoplankton has been eaten. It's been eaten by zooplankton. It's been eaten by tiny little animals like the copepod calanus, which actually occupies most of the biomass, most of the invertebrate biomass in the Gulf of Maine in the summer. And the calanus, these tiny little copepods, their peak productivity corresponds in late June and early July with the nestling period of the seabirds. It's an almost perfect correlation. Now the seabirds are not eating the calanus. This calanus is a tiny little, almost microscopic organism. But the calanus provides the food for the forage fish on which the puffins depend. And one of them is a fish called white hake. And this graph shows you the number of white hake that are brought into puffin burrows at the seabird islands over the years. Hake are actually a fairly large fish, and they live normally fairly deep in the water column. But the larval hake, the small hake, after they hatch on the continental shelf, move into the inshore waters, and they remain in shallow water to feed on the calanus, to feed on those tiny little copepods. So this brings them in close enough to the islands for the puffins to reach them, and they're in shallow enough water that the puffins can dive down and be able to catch them. The same thing goes for herring, which are another very important forage fish. Again, another warm-sensitive fish. These fish need cold water. Their numbers are more variable from year to year. Part of that is because herring are badly overfished in the Gulf of Maine. This is the primary bait that they use for lobster fishing. The effect of climate change on seabirds has really hit home with American and Canadian audiences in the last couple of years, because there's been a number of extraordinarily warm summers and tremendous spikes in the surface sea temperature. We're going to talk about surface sea temperature quite a bit in the next few minutes. And all you have to do is take a look at this chart to understand why. These are surface sea temperatures over the last 20 or 30 years or so, and you can see that starting in 2009, and particularly in 2012 and 2013, sea temperatures in the Gulf of Maine spiked to record levels, and that had tremendous impacts on the entire ecosystem, especially seabirds. You heard Franz talk earlier today about the impact of earlier and earlier springs. Spring has been coming an average of about 2 weeks earlier in the Gulf of Maine. Precipitation is increasing, the sea surface temperature is increasing. There's increased acidification, which is having impacts on animals like those little calanus copepods that have calcium-rich shells, and an overall reduced productivity in the Gulf of Maine. Fish migration is being affected by the temperature. The fish are moving deeper in the water column or staying farther north. There's more river runoff. We'll talk about that in just a moment. This has really significant impacts on the whole marine ecosystem. And also we're seeing southern species of fish moving farther and farther north, some of which are very good for the puffins, others of which are very bad for them. I'm sure most of you have seen this kind of a diagram showing the cycle of global warming. But one of the things that's important to understand about marine ecosystems is that because of the increased precipitation that you get, you have more runoff, you have more rainfall falling on land, it's washing more sediment into the water, and the really, really tiny organic dissolved solids, the particles as small as a virus, are causing havoc in these marine ecosystems because they filter out the blue light in the water. The blue light is what the phytoplankton need in order to photosynthesize, and with that blue light blocked, the phytoplankton, the tiny little plants, are unable to photosynthesize. There's less productivity available for the zooplankton and on up the food chain. So what we've seen in the last couple of years, because of this spike in sea surface temperatures in the Gulf of Maine, was reduced overall productivity in the Gulf of Maine as reflected by reduced numbers of breeding seabirds. The puffin colony at Seal Island, which I showed you a moment ago, dropped for the first time since it was established in 1992. At Eastern Egg Rock, which is the island where the puffins were first reestablished in the early 1970s, we had the first declines after a very long period of increase. It turns out that seabirds are incredibly effective tools for monitoring the effects of climate change on enormous, incredibly complex marine ecosystems. Now, it's not to say that this is easy. The data that you're hearing about today come from scientists who spend months at a time living on these islands that have no running water. They have nothing, there's no food out there, there's no water out there, there's not a whole lot of shelter out there. People go weeks and weeks at a time taking baths in cold seawater and meticulously observing every pair of puffins every time they bring prey back, identifying what prey species they're bringing back, identifying how large it is, and producing as a result this incredibly detailed picture of the productivity of this area. And one of the things that we're seeing is a change in the diet of these puffins. In the past, they fed primarily on hake and herring, those two cold water species that I showed you a moment ago. What we're seeing is that's shifting. For example, the yellow bar there represents something called butterfish. And butterfish are a southern species that are invading the Gulf of Maine. They were never found there until about 5 or 6 years ago. You can see this as well at Eastern Egg Rock. The number of butterfish are increasing. The problem with there's nothing wrong with butterfish. They're perfectly nutritious fish, but they're round. They have a very round body shape. And if you're a small bird that has to swallow your prey whole, it may be too large to swallow. Now in the past, what happened in a puffin burrow is kind of a mystery. If the scientists, the young interns that are working out there, if they saw the puffins carrying prey down the hole, they assumed that all was well. If the adults were delivering fish, the assumption was that everything was fine. The problem is that our video is not working. Let me see if I can get that to. Nope, sadly. Well, I'll spare you. I have to say rather. Okay. Well, how do we? There we go. A little of this goes a long way. This is a nest cam, which Project Puffin put down a couple of nest burrows a few years ago. And it was the first time that scientists really had an opportunity to see what was happening in the puffin burrow. And what it was not pretty. This bird was dubbed Puffin Petey, and this was broadcast on live on the internet, and people got to watch this puffin chick starve to death because it was unable to swallow the butterfish that its parents were bringing into it. It was a pretty painful thing to see. So you have to have not just fish, but the right kind of fish. Now we need to go back to the PowerPoint. There we go. Thank you very much. So there's a lot going on with seabirds in the Gulf of Maine. Some of it is having to do with the breeding season. Some of it's having to do in the winter. Razorbills, which are a closely related member of the auk family, they're closely related to puffins. Razorbills began moving south in a dramatic way a couple of years ago. This is not a picture of the Tel Aviv waterfront. This is Miami Beach in Florida, and those are razorbills flying across the palm trees. These are hundreds and hundreds and hundreds of kilometers farther south than they were supposed to be. Many of them washed up dead on the beaches with their stomachs emptied. And the same thing was happening with puffins. There were hundreds of dead puffins also starved to death that washed up on the beaches that winter because winter water temperatures were much higher than they were supposed to be. And we know very little about what these birds feed on during the winter, but whatever it was they're normally feeding on was not there. Among the other southern species that are invading north are the Atlantic moonfish. Again, if you were a baby puffin, that would not be something that you would be able to swallow. But not every species of southern fish moving north is bad for puffins. The Atlantic saury is a fish, obviously, that a puffin would have no trouble swallowing. Small Atlantic bluefish are oily and very nutritious. And Atlantic redfish, which eventually get quite large, but as in the larval stage, are a terrific food for puffins. These are all southern fish that are moving north. And in the case of the bluefish and the redfish, these are fish that had been badly overfished. The stocks had been badly overfished for many years, and thanks to better fisheries management, their stocks are increasing. Haddock is another fish that's highly nutritious for the puffin. They weren't available for a very long time because they've been so badly overfished. This is a graph up here showing landings from the 1970s, and you can see how in the 1980s, haddock stocks were almost completely outfished, but now these are you can see some of the year classes are coming on very strongly, and what that's meaning is that at puffin colonies like Matinicus Rock in the Gulf of Maine, where it used to be primarily hake and haddock, now other species of fish are comprising a much larger portion of the diet. Some of this is butterfish, which we don't want, but bluefish and redfish and some of the other highly nutritious species, so they're getting a much more varied diet. So this is a result of active management, not of the puffin colony itself, but of the fisheries on which they depend. This past winter in the northeastern United States and eastern Canada was one of the coldest we've had in 20 years, and what that did was it finally brought ocean water temperatures in the Gulf of Maine back down just barely within the normal range. Brought it down by about 0.8 of a degree centigrade, which isn't very much, but was more than enough to reset the clock and bring things back to normal. The spring phytoplankton bloom, this was the phytoplankton bloom last year. This is the norm right there. That's the long-term average. So it was not as strong as it usually is, but it lasted longer. And again, it wasn't perfect, but it was just enough. And so The number of Atlantic puffins breeding at Seal Island rose again, and the number of puffins breeding at Eastern Egg Rock, at the original colony, actually shot up 33% to a new all-time record for the number of puffins that were there. Per nest productivity of the Seal Island colony jumped as well. It doesn't take much. Again, it shows how exquisitely sensitive these seabirds are to what's going on in the Gulf of Maine, and provides a really handy barometer for the overall health of this marine environment. I mentioned that the puffin egg is incubated always for 42 days. It's an enormous investment on the part of the female puffin. The egg weighs 60 grams, the female weighs 400 grams. It's 15% of her body mass. If she's not in really good physical condition, she may have to delay laying her egg until later in the season, or she may not be able to breed at all. And one of the effects that we're seeing from rising sea temperatures in the Gulf of Maine is a later laying date and a later hatch date for puffin eggs, and much more extreme variability. You can see that in the 80s through early 90s, the first hatching dates of the first chicks were relatively stable, and then in the last couple of years, the wheels have completely come off. 2012 was the earliest date, 2013 was the latest date. And early and late are both bad from a puffin's perspective. If the chick hatches too early, it misses the peak of the productivity. If it hatches too late, it misses the peak of the productivity. It's really critical with that one, they only get one shot breeding every year for that chick to have the maximum opportunity to get the best diet possible. So what started 41 years ago, translocating puffin chicks like this as an innovative conservation technique to try to restore a lost, extirpated population of birds, has unexpectedly and without really any forethought on anyone's part turned into an extraordinary opportunity to monitor the effects of global warming on an entire complex and for the most part remote marine environment. So just to wrap a couple of things up here, seabirds are affected by warming climates in many ways. Cool water fish such as herring and hake, on which they are most dependent, are extremely sensitive to warmer waters as surface sea temperatures rise. And at the two colonies that are most closely studied in the Gulf of Maine, a drop of not even 1 degree centigrade produced profound effects on those puffin colonies. Butterfish, which we've talked about a good deal here, are just too large for these fish, or too large for the puffin chicks, although they are not the only southern fish moving in. And new prey species could supplement their diet, but it comes down to active fisheries management. The redfish, the bluefish, the haddock, these are all species that are benefiting from much more restrictive fisheries management in the United States and Canada in recent years. And it shows that even when birds like puffins are facing challenges like global warming, we can impact them in a positive way through fisheries management. And as I mentioned just a moment ago, seabird hatch dates provide a handy way of monitoring this. So in conclusion, the hatch dates are getting later and more variable. These hatch dates are correlated with sea surface temperatures and the chlorophyll bloom. Interestingly enough, the most important changes may not be in the areas immediately around the colonies, but basically upstream, what's happening in the waters to the north of the colonies, because this water is coming from the north. One of the effects that we didn't really talk about is you get more precipitation on land and more fresh water flowing into the Gulf of Maine. That can reduce or eliminate the inflow of these cold water currents. High chlorophyll concentrations near the islands, though, are helpful because that tends to concentrate prey near there. And we talked a moment ago, the hatch dates are really correlated tightly to the sea temperatures. If you'd like to learn more about this, you can go to Project Puffin's website. It's projectpuffin.audubon.org. And if you would like to see puffin chicks that actually happily survived, you can go to the live puffin cam next summer. We have cameras down the burrows. We also have cameras on some of the loafing ledges. And if you can't wait until next year to get your puffin fill, if you go to the Puffin Cam website now, it's playing highlights from this summer, which was the best breeding season in many years, so it's a happy thing. Thank you all very much.
Thank you very much, Scott. We leave questions to the break, okay.